So last part of the this chapter number 3, we discussed how the impulse response can be used to calculate the output of any linear time invariant causal system for any input. And the way we do it is we take the convolution between the impulse response and the input. And we did an example where it was shown that when you take the convolution between the input and the impulse response, your result, of course, were the same as calculating the output using the difference equation itself. So convolution plays an extremely important role in declaring the output for any input, as long as you know the impulse response of the system, or you can figure out the impulse response of the system. So the last topic of this chapter number 3, we are going to concentrate on how many different ways you can calculate or you can perform convolution between two vectors. In general, the vectors that we are using, of course, are impulse response vector and the input vector to calculate the output vector. So there are three ways to perform the convolution operation, and basically all three ways all three ways are similar. The first way is the standard method. The second is putting the equation, the first method, into a graphical form and then operate the convolution. And the third one is putting the graph in the table form and perform the convolution. So let's go ahead and understand all three of them. The first one we discussed again in the last topic, in the previous topics, that is how to calculate the convolution using the convolution formula or convolution equation. So convolution equation or convolution formula is given by this equation or formula, that is h of k when convoluted with x of k, then it is an infinite summation between h of k and x of n minus k to calculate the corresponding y's of n. And then if you expand this, of course, for different values of k, that's going to be h of minus 1, xn minus 1. So basically we are going and plugging in the values of k over here and perform the summation operation. Convolution operation is commutative, so either you carry out hk convoluted with xk or x of k convoluted with h of k. You will get the same result. So convolution operation is a commutative operation. Since our systems are causal systems, so we don't really have to perform convolution from k is equal to negative infinity. All the values before our reference n is equal to 0, if the input is coming at n is equal to 0, and then of course the output cannot arrive before that. Hence our convolution is a causal process, or for causal system it starts at k is equal to 0. Let's make it even simpler, right? So there's one example over here where we're going to use the convolution formula to figure out the impulse response between the output between the impulse response 256 for the system and for any input 8 2. Now make sure when I write this, basically I'm using MATLAB or Octave vector format. That means 0 1, and this means 0 1 and 2. So 0 to 2 and 0 to 1, all the values between those 2 points. So what we are using here is a convolution formula, this formula right here that you see in front of you. And when you expand that right here, when you expand that, we know that k is 0 1 and 2 based on the values of h of n, right? So whichever value is we are using h of k x n minus k, so whatever h of k is, that's going to be the limit of k. K is equal to 0 to 2. And then you expand this h of 0 x of n plus h of 1 x of n minus 1 and h of 2 x of n minus 2. Now in this system, again we are assuming that the value of x is 0 anywhere else beside except at n is equal to 0 and n is equal to 1, where 8 and 2 are the values. So there are no initial conditions. That is, the system is memoryless. System is not holding any memory of the input or the output. Now sometimes system has memory, so it is holding some initial conditions, that is y of -1, x of -1, and we did one of the problems like that earlier. So all we have to do is to plug in the values. Y of 0 is x of 0, h of 0, x of 0, we are using n is equal to 0. So in this equation, wherever you have n, you're just going to put a 0 over there. So h of 1, x of -1, and h of 2, x of -2. Now x of -1, x of -2 are 0, so the only thing that will be left will be h of 0, x of 0, and then that's going to be 16. Y of 1, h of 0, and then you're going to put n is equal to 1 in this sequence, in this formula, sorry, and that's going to be h of 0, x of 1, h of 1, x of 0, h of 2, x of -1. So again, x of -1 is going to be 0. So you're going to have h of 0, x of 1, that is 2 times 2, 4, and h of 1, x of 0, that is 5 times 8, 40. So your answer is going to be 44. And similar way you can expand this. Now remember, I think we discussed this, or maybe we have not discussed this. Anyways, the length of y vector, that is the output values, non-zero values, will be the length of h vector plus the length of x vector minus 1. So 3 plus 2, 5, minus 1, 4. So length of output is going to be 4. There will be 4 non-zero components in the output, and you can see them over here. Y of 0, Y of 1, Y of 2, and Y of 3, they are non-zero, and then rest of them will be 0. As you can see, when you're shifting the series, then for Y of 4 you will have h of 0, x of 4, h of 1, x of 3, h of 2, x of 2, and of course x n only exists for 0 and 1. So h of 2, x of 2 is 0, x of 3 is 0, and x of 4 is 0. So it is going to be 0 everywhere else except for n is equal to 0 to 3, and that's the length of h plus length of x minus 1. Alright, let's look at digital convolution using graphical method. So if we go back to the equation right here, and if we use, we can use any equation, but generally we use this equation right here. And if we write down y of n is equal to x of, for k is equal to 0 to infinity or whatever, so that's going to be x of 0, h of n plus x of 1, h of 1 minus k, x of this should be n minus k, sorry, n minus k, or n minus 1, n minus 1, and plus x of 2, h of n minus 2, and so on and so forth, right? Now here is the question is, this is a summation series. You're multiplying h of 0, x of n, x of 1, h of n minus 1, n minus 2, so on and so forth. So here's the question: what is h of n minus k graphically? We know what is xk graphically. K is just a variable, remember, right? So whatever x of n is given to you, x of k is the same thing. We're just swapping the variable. But what is h of n minus k? If we know h of n minus k, then of course we can graph h of n minus 1, we can graph h of n minus 2, and we can take the product between h of n minus 1 and the first value of x of 1, x of 2, h of n minus 2, and stuff. Alright, so what I'm explaining in that topic is exactly, first we will start with what is h of negative k. So h of negative k is basically when you have h of k or h of n, you go ahead and flip that about y-axis. So your h of 0 is still h of 0, your h of 1 becomes h of negative 1, your h of 2 becomes h of negative 2. So this is h of k, the original sequence, and this is h of negative k. So once again, anytime you're calculating h of negative k or h of negative n or whatever the the argument is, the variable is, basically what you're doing is you're flipping the sequence about y-axis, mirroring it about y-axis. Now what is h of 1 minus k, 2 minus k, 3 minus k? So again, if we go back, we have n minus k, right? So you have, when n is equal to 1, if you're calculating y of 1, then it's going to be 1 minus k. When it is 2, it's going to be 2 minus k. This is 2 minus k. And of course, based on what value of k you have currently, is going to be that value. So basically what we are looking for is what is n minus k. 1 minus k, 2 minus k, 3 minus k, so on and so forth. So 1 minus k is basically this sequence, but you shift it towards right by one time instant. Again, h of negative k sequence shifted towards right for one time instant. So what's going to happen? Whatever you see here is going to be at n is equal to, or k is equal to 1. Whatever you see at negative 1 is going to be at k is equal to 0, and whatever you see at negative 2, it is going to be at k is equal to negative 1 or n is equal to negative 1, whatever you want to call it. So this sequence, when it will be shifted towards right one time, that's going to create h of 1 minus k. If it is shifted twice, it's going to create h of 2 minus k, and so on and so forth. So look at this example. Using graphical method, we do the convolution for the same x and same age that we had here. So where age was 256 and x was 8 and 2. So age is 256 and x is 8 and 2, as you can see over here. So we are plotting x of k, 8 and 2 for n is equal to 0 and 1, or k is equal to 0 and 1. And then this is my h of negative k. So my h of k is supposed to be 2, 5 and 6. 2, 5 and 6 for 0, 1, 2, for k is equal to 0, 1, 2. That should be my h of k. Now when I flip this sequence, I'm gonna have 2 still at 0, 5 at negative 1 and 6 at negative 2, and that's what you see over here. 2 at 0, 5 at negative 1 and 6 at negative 2. So for your y's of 0, what you're going to do is basically whichever components of x and h of negative k, they are aligned, you multiply them together, and that's going to be your result. So the only component that is aligned is x of k and x of 0 and h of 0. So you multiply those together and your result is 16. Okay, now this is x of k, h of 1 minus k. So you're shifting it towards right by one time instant. And again, whichever is aligned, you multiply them. So this component is aligned with x of 2, and this component, which is h of 2, is aligned, or h of 1 is aligned with x of 0. So again, remember, y of 1 was h of x of 0, h of 0 plus x of 1, h of x of is going to be x of 0 h of 1 and x of 1 h of 0 using the formula, right? Using the formula, that's what will be the expansion of y of 1 using the formula summation k is equal to 0 to 2 x of k h of n minus k. That was y's of n, right? So for y's of 1, it is going to be, of course, this x of k is going to be the same, x of 0 h of n minus 0, so n plus x of 1 h of n minus 1 plus x of 2, and there is no x of 2, so we're not going to even go over there. So when you put n is equal to 1, that's going to be x of 0 h of 1 x of 0 x of 1 h of 0. So x of 0 h of 1 x of 1 h of 0, right? So it's coming directly from formula, but it is easier to visualize that you're just shifting it towards right, and then you're multiplying the corresponding components that align with each other. Likewise, you shifted it 3 times, h of 2 minus k, and again the components that were aligned, you multiply them together to calculate y's of 2. Then you shifted it, sorry, 2 times, not 3 times here, and then you shifted it 3 times right here, and the only component that is aligned is x of 1 h of 3 or h of 2, sorry. So you multiply these together, and then you shift h of negative k one more time, that is you're shifting it 4 times. So now, as you can see, no component is aligned, hence y4 will be 0. So again, we will have 3 values of y, non-zero values of y, as we saw earlier, and that's the graphical method. So in summary, what is graphical method? You plot x of k versus k, and you plot h of k versus k. Then you flip h of k to make h of negative k, you flip it about y-axis, and then the first value of y's of 0 is going to be x of k sequence multiplied by h of negative k sequence. So whichever component is aligned, which will be only the component that is at k is equal to 0 and 0, those two will be aligned. That's going to be y's of 0. And then you shift h of negative k sequence towards right. It's going to be h of 1 minus k, h of 2 minus k, h of 3 minus k, 4 minus k, and every time you shift it, whatever components are aligned between x of k, h of 1 minus k, x of k, h of 2 minus k, you multiply those components, and then that will be the corresponding, and then add them together, and that will be the corresponding value of y. So very easy method, but you have to graph it, so it may become lengthy. So the last method actually is perhaps, I think, the most simplified method. Basically, what is the last method? You're putting this graph in a table form, as simple as that. So if we go and look at the same example, we have x of k 8 and 2, we have h of k 2, 5, 6. So now we take h of negative k, so we flip it about y-axis. This is our y-axis 0, so we flip it about y-axis. So 2, 5, 6 become 6, 5, 2. So flip this about y-axis. So, and then you multiply the corresponding components whichever is aligned. So 8 is aligned with 2. So your y of 0 is going to be 8 times 2, 16. None of the other components are aligned. And then you shift h of negative k towards right in the table. So you shift it once, 6, 5, 2. Again, whichever component is aligned between h of negative 1 minus k and x of k, you multiply them and add them. So 5 times 8 and 2 times 2. Result will be 44. Once again, you shift 6, 5, 2 one more time. Which components are aligned? 6 times 8, 5 times 2. 6 times 8, 48, 5 times 2, 10. 10 plus 48, 58. Again, we shift them one more time. 6, 5, 2, 6 times 2, 12, and those are the only two components aligned, so 12. And then when you shift it one more time, none of the component will be aligned and your result will be 0. So this is digital convolution, and these are the three methods to calculate digital convolution.